How's everybody? Let me share my screen. And actually, settings. All right. Okay. So welcome, scholars. Let's see. I think that so there's here. Let me do this real quick. Okay. All right. So no real announcements. Let's see. I kind of want to let me glance at the calendar real quick. So as I glance at the calendar, right, today is the 10th, right, of April. So today is going to be the last of the new material. We're going to be working on section 4.6, integration by parts, right? I want to say this Sunday, exam 2 becomes available. It covers chapters 3 and 4. You can earn up to 100% from this Sunday till next Sunday. Again, so exam 2 should become available this Sunday. It'll cover chapters 3 and 4. You can earn up to 100% from this Sunday to next Sunday. After next Sunday, the highest you can earn is at 95%. So let me see. I know the hard deadline for all assignments, like the week of finals, is that first full week of May. So that's May 6th through the 10th. So the hard deadline for all assignments should be May 10th, right? So what that means is that, you can still access everything. Now, if you're going back and doing old assignments, my recommendation is to prioritize your exams first. You can still earn up to 95% on exams. Again, exam 2 becomes available this Sunday. And still unlimited attempts. The system is set to take your highest score. Once you get the exam scores to wherever you'd like, right? So you can still get them to an A right now if you want, which is my recommendation if you're able to do it. And then I would encourage you to prioritize the homework last. Let me see something real quick. If I go, let me see how quickly can I pull it up. Here. What is it called? Sort things. Okay, created, date created. Okay. Let's see if I can find it. It's not that one. Okay, no, Shyster. I am not seeing it. Is it this one? What is this? No, I don't think this. Oh, I think I know. Oh, but I think I cleared it out. Shyster. Give me just a moment, gentlemen. Where else could I have it? Let's check here. I think I had it here at one point, and then I think I removed it. Yeah, Shyster, I can't find it. Waldron. Let me check another source. Give me just a moment, gentlemen. Right here. If I go here. This one. Let me see. I did that. Yes. Shyster, I can't find it. Oh, where is this thing? Because I know it's in that form. I don't have that list. Oh. Okay. I can't find the names. I'm just unorganized when it comes to this. But we do have two scholars in this class that actually received the math awards yesterday. I think there was a communication error because they had to submit names and emails, and so I guess for whatever reason, I thought that they would like do an email blast, and maybe they did, maybe they didn't. So at the last second, I realized that I may not have notified you guys, right? You may not have been notified. So you'd have to check your email. But so there are two students in this course that it's not a guarantee like A or anything, but it's like when I went to look at the grades at that time, they were the two at the top. I was trying to find their names, so you'd have to check your email to see it. So congratulations to those two students. Because whatever notes I had, I think I got rid of them. But yeah, so that's going to be in your email. So just kind of look out for that. And so if you did receive an award, if you just stop by the math office, it's going to be there. Okay, yeah, I can't find the names though. I'd have to like dig a little bit deeper to find those. Let's see. But yeah, and I was like, I felt bad because I was like, dang, they missed out on like free food. They had like boneless wings and meatballs and stuff like that. It was decent. It's just an event that like the math department does like yearly. And again, I don't know. I thought that they were going to email everybody, and they didn't. I don't think that they did. And I was like, dang, I think I was supposed to email you guys. So that was my bad. Let me see if there's anything else. Where else could it be? I think I screenshot it at one point. Let me see. I had to check it later. Let me see. Did I save those things? I may have. I don't think they will be here. I had to check it later. Okay. I can't not check it. Give me a moment. Let me go like this. I'm gonna stop my share. And let me go here. That's fine. Right here. Here. Come on. I think it's gonna be here. Can we like zoom out some? There we go. That's much better. It's not that one. Where is it? Step far back. It's definitely not. It's not those. Check one other source. This other source, if I don't see it here, then I'm gonna have to let it go. It's not there. Screenshots, where's screenshots? Right here. Yeah, I don't see it. Yeah, because I remember like, let me see if I look at the names if I can see it there. I can recognize the name because I basically did it in my grade book and then I undid it when I was calculating grades last spring of 24. We go right here. That's college algebra. College algebra. Here it is. Okay, let's see if I still have it here. I don't think it's still in order. Yeah, because I had to put it back in order. Let's see. Is it this student? No, I don't think so. I know that's one of them. I got one, and I think this is the other one. I think this is it. Okay. I'm like 90% sure these are the names, right? So congratulations to Mr. Aaron Tatum and Jabari Martin Edwards, right? So now again, at that time, they were at the top, right? These are the top two. So that's not a guarantee you're finished or anything. We still got the rest of the semester out. But for those two students, if you stop by the math office, there's an award there that you can pick up. And it's something that's great for resumes, depending on what you're trying to do going forward. So congratulations, gentlemen. Okay, so let me bring this back. Let me get rid of this. So I'm not showing sensitive information. Let's get rid of that. Glad I was at least able to recognize the names. I'm gonna share my screen. I feel like I need one of those like applause buttons to press and it like cheers for you. Okay. So we're here. Okay, so yeah, so we had the math award ceremony yesterday. Let me see. Again, today this is going to be the last of the new material. All right, so and then basically from here on out, we're going to be reviewing. Let me glance one more time at my calendar. So we have how many sessions? We have Monday, Wednesday. I think the last day is the 24th, which is so we have after today we have 4 sessions. And so basically each session we'll do a chapter. Like so next this upcoming Monday, we'll just focus on chapter 1. On a week from today on Wednesday, we'll focus on chapter 2. The following Monday, we'll focus on chapter 3. And then that final Wednesday, the last day of class, which is April 20. Is that right? Actually, I think we got another day in there. Yeah, I think the last day is actually May 1st. Yeah, that sounds right. So we might have a couple of days in there. I can actually check another source because this is something we need to be clear about. So maybe we can take next week to review for exam. It's kind of the same thing, but we can review for exam 2 for next week, and then the week after we can start reviewing for the final. Last day of class, I think I have it here. I'm just checking the syllabus real quick. So May 10th is the hard deadline. Usually it's like the week before, so that should be May 1st. Let me see. I have my important dates in the syllabus. Spring break, Good Friday, right there. Review, yeah. So we do go to May 1st, right? So what that means is, next week actually might kind of be a toss up. Like I might sometimes what I've done in the past, it's a little blasé, but it gives the energy an opportunity to reset. During the exam weeks, oftentimes what I would do is like just make myself available for questions. So I'll like show up. You just show up and get your attendance. If you don't have any questions, more than likely I'll let you go. And so that'll give the energy a time to reset. If you guys, and you can ask me questions about anything, even the exam that you're going to be working on. Like if you have a question, you can screenshot it, send it to me, and we can work on it together during class. So maybe you can take advantage of that. Probably more than likely what I'll do next week, I'll probably just show up and just make myself available for questions. You can ask me questions about anything that you have access to. If you don't have questions next week, then I'm more than likely to let you go. And then we'll start reviewing for the final the week after. So we can just kind of keep a proper rhythm. Okay, so we'll kind of play it by ear next week, but definitely the week after that, we're going to start reviewing for the final. Okay. As usual, if you have questions, feel free to unmute yourself to get my attention, and we can talk about it. Yeah. So, chapter 4 integration, right? This was our original goal, was to get to the end of chapter 4. And we're going to be working on section 4.6, integration techniques. We're going to be doing integration by parts, right? So last time I know we did substitution, right? We did several examples with substitution. Integration by parts is similar but different, right? So let's just see how it unfolds. A few objectives. And log. I almost forgot in that split second. I had to think. I think it's this student. Okay. All right. So a few objectives. 1, evaluate integrals using the formulas for integration by parts. And then 2, solve applied problems involving integration by parts. Okay, so this is all about integration by parts. All right, so integration by parts, if we have the integral of u dv, then that's going to be equal to uv minus the integral of v du, where u and v are like expressions, right? So, we're going to be given an integral. We're going to well, let u be this and let dv be this. And then we kind of go back and forth and we'll find it's basically 4 parts. U, du, v, dv. We're going to find all 4 of those parts, plug each part into this formula, and then see can we take the integral. Because if we try to take these integrals directly, we won't be able to do it. So, right. So this is, again, this technique is called integration by parts. Let me see. Tips on using integration by parts. Slide 1 of 2. 1. If you've had no success using substitution, then we try integration by parts. Use integration by parts when the integral is of this form, the integral of f of x gx dx. All right, so f of x times g of x dx. and match it with the integral of the form, the integral of u dv. By choosing a function to be u equal to f of x, where f of x can be differentiated, and the remaining factor dv equal to g of x dx, where g of x can be integrated, right? And then find du by differentiating v, find du by differentiating and find v by integrating. If the resulting integral is more complicated than the original, make some other choice for u and dv. And then to check your solution, differentiate, right? That's a mouthful. This is going to be more easily digestible after we work a couple of examples, right? So let's just look at an example or two, right? So we have this guy. So now, let me think. We know, have we not talked about the integral of? Okay, so let me think. When that's a -1, no, that becomes -2. And we know the derivative of natural log. Okay, so let's do this. Where's my pen? Let's just try integration by parts, because I was like, don't we know this? But I guess not, right? So let's just try integration by parts. So now the way it goes, we want to identify our u and we're gonna find our du. I guess that's fine. And then we'll have our v, and we're gonna identify our dv, right? So u is something that we can differentiate. We know the derivative of natural log, so we can let u possibly be natural log of x and let dv be dx. Okay. So then to find du, the derivative of ln is du 1 over x, right? And the integral of dx is what? X, right? Because if we take the derivative of x, we get dx. Okay. So with this u and this dv, the original integral, we can rewrite it as uv, right? So that's going to be x natural log of x minus the integral of v du. So it looks like if we say v times du is going to be x over x, which is just, oh, and there's a dx here. There's a dx there. So then it's just going to be dx. That's interesting. So now we can actually integrate dx, all right? The integral of dx, I think it's just x. So then it looks like this result is x natural log of x minus x plus some constant of integration. Okay. You know, because like when we tried to integrate natural log, I was like, well, is that going to be 1 over x? I was like, no, the derivative of natural log is, 1 over x, right? But we don't have 1 over x, right? If we had 1 over x, then we knew the integral would be natural log, right? So for this one, we ended up using the integration by parts, and we got it to work. Okay, let's try another one. And again, integration by parts, formula is, just to kind of do a quick recap, I'm pretty confident in this. The formula is when we have the integral of u dv, that's going to be uv minus the integral of v du, right? So we're finding all 4 of those parts, and we're plugging it in. Now, when we did this one, we got this x natural log of x minus x plus some constant of integration right here. X natural log of x minus x plus some constant of integration. Let's try another one, right? Let's just try another one. Okay, evaluate. Okay, so again, integration by parts goes, when we take the integral of u dv, that's going to be equal to uv minus the integral of v du, right? So we need to find those different parts. We're going to have our u and our du, and then our v and our dv, right? So we need to choose an appropriate u and dv. So u, let me see. We want dv to be something that we can integrate now. We just found the integral of natural log. Maybe we can use that result. We probably could. I'm really tempted to use the result we got in the previous one. let me try not using that result first. All right. So dv, we want to choose something that we can integrate. So we'll say x dx, and the integral of that guy is going to be what? X squared over 2. I think that's actually going to make it worse. Let's see. Let's keep going. So that's going to be what? X squared over 2. And our u could be natural log of x. So then our du would be dx over x. Okay. So now notice if we say u dv, if we say this guy times this guy, you know, the integral of u dv is where we're starting, right? So then we take the original, we're going to say the original is going to be uv. So we'll say x squared over 2 times the natural log of x minus the integral of v du. Okay, does that help? I think it does. All right. We're going to have x squared over x. So it looks like we're going to have 1/2. Just moving the 1/2 to in front. It looks like it's x dx. And what I did there, again, I said this times this. So then x squared divided by x was just x. I moved the half in front. Now we have an integral that we can actually take, right? So then if we just keep going, we can do 1/2 x squared as a natural log of x minus 1/2. Now the integral of x is going to be what? X squared over 2 plus some constant of integration. So ultimately, it looks like we get 1/2 x squared natural log of x minus x squared over 4 plus some constant of integration. So we were able to finish it, right? Now we can kind of test it because, you know, originally we had the thought, I was like, well, we just took the integral of natural log, you know, so maybe we could have used that result. We can check it, but now if we want to check this guy, right, we could take the derivative, right? Let's just do a quick check and see if we can. No, that's going to be integration. That's going to be the product rule. I don't feel like doing it. I'm being lazy. But again, if you did want to check it, you would just take the derivative and you should get back to where you started. Okay, so let's see, how do we do? We got x squared over 2 ln x minus x squared over 4 plus c. Let's see what they chose. Oh, man. Oh, attempt number 1, right? So they let u be 1 and dv be that guy. This will not work because we don't know how to integrate this guy, right? So we let that be. That was just a guess. Huh. Yeah. So they let their u be x natural log of x, and that made it worse, right? So let's try that. That was attempt number 2. So now, yeah, because again, we want to choose a u that we can differentiate, and we want to choose a dv that we can integrate, right? So they said let u be natural log of x and dv be x dx. And I guess we just got lucky that we chose what we chose originally. But again, my thought process was I want to choose a u that I can take the derivative of, which is, I feel like taking the derivative oftentimes is easier. So I really focused on trying to find a dv that I could integrate. If I realized that, like, if this was in my dv, that was going to be harder to integrate. So I just kept that out of the dv. So that's why I chose this one, right? But again, it might, sometimes it does involve a guess and check. Like you try a u and a dv. If it doesn't work, you try a different one, right? In theirs, they tried at least 2 different, you know, orientations or whatever before they found something that worked for them. And then they got the same thing that we got. Let's just try another one. Again, with something like this, it's just exposure. You keep trying until it sinks in, right? So again, the idea here, if we're doing integration by parts, so we're given with the integral of u dv, right? So we have to find a u, we have to find a dv. Then once we find a u and a dv, and we find the remaining parts, once we have all 4 parts, then we can say uv minus the integral of v du, right? So again, we're looking for u. We're gonna calculate du. We're looking for dv. We're gonna calculate v. Okay. So dv wants to be something that we can integrate. We can integrate that guy. Let me think. Does that work? Do we have to do a u substitution first? Or if that's our u. Okay, I think I got something. I'm tempted to try. Does this work? Hang on. If that's my u, I want something that I can integrate. So I'm tempted to do, let my u be 5x plus 1, and my dv be x dx. Okay. Now let me think. We got u. So that would be what? The square root of u. Because we can integrate that guy. The derivative here, we want u dv. We have the square root of that guy. So then maybe, do we need to square this? Would that help? Ooh, that's going to make it much worse. Let me think. If I did u substitution, if that was my u, my du would be what? Just like 5 dx. That doesn't help us. Let me see. Is there another? Let me think. Because we got the dv, right? So that's going to be x squared. I mean, we got the v. That's x squared over 2. Okay. And our du would just be 5 dx, but it's not matching exactly, right? We got, if we say u dv, we're missing our square root, right? Maybe we can work with it though. Let's just keep going and see what happens. All right. Maybe I'm just overthinking it. So if we make these adjustments, it looks like we have the integral of the square root of u, right? That's the thing that's throwing me off. Dv. All right. And the only thing I could think is, instead of that being u, make it u squared. Like if we just make it 5x plus 1 squared, that way when we plug it in, then we'll get the desired result that we want, right? Let me think. Or I mean, make u the square root of 5x plus 1. But it feels like that's making it worse. Claude. Let's see. Let me think about. Now we could choose a different u. We could let u be the square root. Will that help us? It might. Let's try. So if we make the u square root, like this, if we do this, then when we go to take the derivative, the 1/2 comes down. We're going to have 5x plus 1 to the power of a negative 1/2, and then it's times 5. See, I feel like it feels like that's making it worse. So now we can do u dv, right? If we say u dv, okay. So I think now we're in the clear as far as having the proper form, because we can say u dv and that works. So now if we try to apply the formula, let's see what happens. So uv, maybe, let me think. That times that, does anything cancel? Those go out in front, and it's gotten worse. Yeah, I think it does make it worse. So let's try something else. All right, I think that this combination is making it worse. So let's see if we can think of another one. If that was our u, we tried that as u, something that we can integrate. I still have this urge to do u substitution. I think there is another trick that I'm just forgetting. if we try substitution here, right, instead of integration by parts, like I'm tempted to do let u be 5x plus 1. Then our du would be 5 dx, right? So then if we try u substitution, we would have the integral, let me see, we have the square root of u, and we're missing an x on the outside. Oh, it's coming back to me now. Okay, if we need an x from right here, we can pull it from here actually. So we made this our u. So we can get x, we can get an expression for, we can solve for x from here. We'll have u minus 1 equals 5x. So then x equals u minus 1 over 5, right? I think we can put that in front. Yeah. Okay. Okay. I think we're there. Because okay. So then our du, there is a 5 out here. Our d, we got a du here. That's, hang on. We're almost there. We're like right there. Hang on. I think I'm doing substitution, right? So if that's our u, we got that, and then we have an expression for x, and then we need an expression for dx, right? So from here, dx is going to be du over 5. Okay, I think we have all the parts. Okay, so let me just plug in each individual part. So first we started with the square root of u, right? Dx is du over 5, and x is u minus 1 over 5. Okay. I think we're there. Maybe. So u minus 1 over 5. Let me turn this on real quick. Settings. Like that. Okay, let's give it a go. Now we can pull out that constant. So the 1 over 25, we can just pull it to the front. Okay. So then, okay. If we distribute, we get u to the power of 3 halves minus u to the 1 half du. And I think we can integrate this guy. Wow, it actually worked. I think we're there. So this isn't like the traditional integration by parts. This was like an alternate. This is actually u substitution, because I couldn't get integration by parts to work in this one. So I was like, well, let me try u substitution. And then as I was doing it, I remembered this trick where we had that lone x. So from our u, we can pull the x from the u. And we got x was this guy, all right? So then once we just kind of changed the form, all right? We had an expression for x. We let 5x plus 1 be our u, and we had an expression for dx, right? So then once we change the form, I think we can integrate this guy. So let's go ahead and do it. So this should be 1 over 25. We're going to have u to the power of 5 over 2 divided by 5 over 2 minus u to the 3 halves over 3 halves. And then ultimately, we're going to have some constant of integration. Okay. If we flip and multiply, let me see. So flip and multiply, that's going to be what? 2 over 5. So that's 2 over 125 u to the power of 5 halves. 2 over 3. So 2 over 75 u to the 3 halves. And then we just back substitute u, and I think we're there. I am, let me put it here for right now. I'm gonna rearrange it to make it look better. But we're getting 2 over 125, and our u was 5x plus 1 to the power of 5 halves. I'm gonna move this stuff. That's why I'm doing a different color, so I can isolate it, because I'm just out of space. 2 over 75. Our u is 5x plus 1 to the power to the power of 3/2. Okay, let me just move this stuff around. Give me just a moment. And we'll do a recap. Now, this one, again, we ended up not doing integration by parts. We actually did use substitution. Undo. Just missed the last thing. Come on. Got a nice little rain going. Okay. Let me just move these items around. So I want this guy. I want it about here. Okay. This was the result we got. I'm just going to put it in purple. Leave it as purple. And I'm just going to resize everything. Okay. Just to expand it. All right. So yeah, again, we tried integration by parts and we couldn't get it to work. So then we abandoned integration by parts. And so it's like, well, let's try just use substitution. I don't know, something in my psyche was like, I think it's a use substitution. So I was like, well, let me just try. I wasn't really sure, as you can clearly tell, right? But we got there, right? And I kind of do that intentionally because just to kind of showcase, that's what it takes. Like first you try something, if that doesn't work, you try something else. You just kind of have to keep, basically this experience is like you're collecting a bag of tricks, right? Or a bag of like mathematical tools. And so you try integration by parts. If that don't work, okay, maybe try a different U. Okay, that didn't work. Maybe let's try U substitution, right? You just kind of have to keep trying different things until something comes through. Let's kind of compare. Oh, and we need our plus C. Let me see. What I'll do, let me move this guy. I am going to duplicate this guy. Let me undo. Duplicate. Style. Is that the right purple? It just started raining and it's so soothing and therapeutic. Like nature is so interesting to me. Like it can be healing and it can be devastating. I love nature so much. Okay, let's see how do we do. So we actually were able to integrate it. We got a result. We got it to something that we could integrate, provided we did everything proper. Let's see how do we do. They get these larger numbers for. They got 4 over 135 and 4. We might be missing a term somewhere. I think we missed 2. I see that 2 there. We're not far off. I think we missed a constant somewhere. Okay, let U be this. No, it looks like they did do integration by parts. Okay. Well, that's fine. I mean, okay, that's okay. They got 2. Is that the final thing? That is the final thing. 4 over 375. So we just got our constants off. X. I think we're missing some things. Let's go back. Okay. Oh, I think I did my integrals wrong. Yeah, I think what I did was wrong. Let me think. Yeah, I didn't even check. So when I take the derivative there, I forgot the inside part, right? I think that's what I'm missing. Okay. It's close, but I think we're off. So, and I guess I started to let my DV be that guy, and I was a little nervous about it, but I don't know why I didn't just try it. Right here. The DV, 5x plus 1 to the 1/2. So then the integral of that guy, you still add 3. You add 1, you raise the power, but then I think you got to divide by the derivative of the inside. So you got, which is just going to be 5. And that's what I forgot to do. I think I could go back and do that with mine. Like right here, I think we're not far off right here. So, where is it? We got our u, we rewrote it like this guy, and that's fine. And our dx is fine, all right? So I feel good about this because this expression for x is good, this guy is good, this guy is good. 1 over 25 comes out right there. That's a half, and that's a whole. So that's u to the 3 halves. This one is good. Minus u to the half. So then when we integrate, I think no, we got the 5 there. I think we still need to divide by another 5 here because, we got to check. When we take the derivative, do we get the proper expression? And I think there is another 5 in there, right? So, but I don't think it's as straightforward as multiplying that by 5. This is close. Again, the error, I'm just going to highlight the error. I know the error is like in here. That's what needs attention. For the sake of time, I'm going to move forward. I'm not going to get rid of this because it's not far off. This is wrong, but it's something there that I had to think about it a little bit more to get down to the bottom of it. Because again, what we could do is if we check by taking a derivative, do we get the proper expression? And I think we're missing some constant that we need to divide by, which is I think a 5. But when I do the 5, see that one is there. I get in the 15. Let me see. I think actually 5. It's almost there. I got to think about it. But I know I think we need to divide by 5 or something there. So it's actually not far off. I'm going to just kind of put a pin in it for now. Because there's a constant that we're missing. I'm getting my 15 there. And I'm getting 625 there. And I feel like something should cancel somewhere. Siri, what's 15 times 75?
15 times 75 is 1,125.
Right here. See, there's a 3. Where's that 15 coming from? Okay. So, yeah, I had to think about it, and I don't want to eat up you guys' time. So the way they did integration by parts, that I thought about it for a split second, but I never tried it, right? So the u is fine. That's easy to differentiate. They let u be x. The dv that they chose was 5x plus 1 to the half, right? So they let that be their dv. So then the integral of that guy, we add 1 to the power, right? So we get 3 halves over 3 halves. So it becomes 2 over 3. But then we also had to divide by the derivative of this guy. So that's where that 15 comes from, right? So then this is going to be our v. And I just avoided it because, I was like, well, maybe that was going to be weird. But, we can, it's doable. So we got this guy and we got this for our du. So then when we say uv minus the integral of v du, yeah, we get this guy. So then I think we add 1 to the power, so it becomes 5 over 2 divided by 5 over 2, which is going to become 2 over 5 times 5, 2 over 15. Yep. So it comes here, and then you just crunch it. Okay. Yeah, when I saw this, I was like, I was avoiding it, and I should have just tried, right? So I should have just tried. So we could do that. Let's try some more. We still got a solid 30 minutes. I'm going to leave this one. Evaluate. Oh, we did this one earlier. I think we can just use the result from earlier. It wouldn't hurt to showcase integration by parts again. Let's see. I think I'm gonna just use the result from earlier since we did it earlier. We got it right. I think it was natural log of x. This one. I think that's it. Let me just copy that. Copy. Go back to example 4. Yeah, let's paste. Right, we're just going to use this result. Okay. So then, if that should be equal to x natural log of x minus x as x goes from 1 to 2. So then when x is 2, that's going to be 2 natural log of 2 minus 2 minus natural log of 1 is 0, so it's just going to be a minus 1 left over. So then ultimately it looks like it's 2 natural log of 2 minus 1. Okay. I think that was okay. 2 natural log of 2 minus 1 is there. Okay. Let's give this one a go. It says the rate of change in the population of bacteria T hours after antibiotic treatment begins is estimated by this guy, where P prime is the rate of change of the population in thousands of bacteria per hour. Assume that when the treatment begins, the population consists of 1.5 million bacteria. Find the population of bacteria after 24 hours of treatment. Okay, I think they want us to integrate. Okay, what is the total change in the population of bacteria from 24 to 36? 24 hours, 0 to 24. So I think we're just finding, let's go ahead and find the integral of this guy and then proceed from there. We just need a blank page. This is slide 21. I know you're not that shape. Copy. Back to slide 21. Paste. Okay. And let's take the integral of this guy. So we have P prime T e to the negative 0.04 t. That's a 4. Okay. And paste. Okay. Okay. So if we're basically what we're trying to do is find the integral of t e to the negative 0.04 t. Okay. So, okay. Let's let our u be t. That means our du is dt. And then our dv, something that we can integrate. So let's do e to the negative 0.04, it's not a 4, t. And so that means our v should be, I think it's going to be a negative e to the negative 0.04 t over 0.04, right? So that way when we take the derivative of e is itself times the derivative of that power. So it's going to be times 0.04 or negative 0.04. Double negative becomes positive, and the 0.04 is canceled, right? I think this is good. Okay. So now if we take the original, we're going to say UV. So we're going to have, let's see, that's what? 10, 100, 4 over 100. So 25. Okay. So U times V, looks like it's a negative 25 T e to the negative 0.04 t minus, that's just U times V, minus the integral of V du. V du. Okay. So it looks like we have a double negative at play. So this guy is going to become positive. Dividing by 0.04 is the same as multiplying by what? 25. So I'm going to bring that 25 out here. And all that we're left with is e to the negative 0.04 t dt. Okay, and I think this is easier to integrate than the original. So then this first part just comes down. T e to the negative 0.04 t. The integral of that is going to be itself, 25 e to the negative 0.04 t divided by, so it's going to be another negative. So I'm just going to go ahead and change it here. 0.04. right, so that's the same as multiplying by another 25, plus the constant of integration. All right, so let's just kind of bring it all together. 25 t e to the negative 0.04 t minus, it should be 625 at this point, e to the negative 0.04 t, plus some constant integration. So when we did it, we got this. I feel pretty good about this one. Find the population after 24 hours of treatment. So the population based on time. So then we should just be able to plug 24 into this and get a result. Yeah. So let's use the calculator. Now, what I'm tempted to do is just use the original, all right? Like, because I think we can calculate integrals in here. So like, for instance, if I go to y equals and I put x times e to the power of negative 0.04x, right? We can just put the original in. And then I think if I go to math, we want the integral, which is number 9 of that function we just put in with regards to x. And we want to evaluate this as x goes from, I think 0 to 24 should work. 0 to 24. Let's see. I think it's 155,956,214. I think these are in millions. If this doesn't work, let me try one other thing real quick. Minus 25. We said what after 24 hours? So 24 e negative 0.04 times 24. Okay. Minus 625 times e negative 0.04 times 24. Oh, okay, I see. Okay. So they gave us, okay, there's a little bit more we need to do. Because they said that assume that when the treatment begins, the population consists of 1.5 million bacteria. So that means that when time is 0, so we can actually go a little bit further. Let me, before I look at it, let me duplicate this slide. And I'm gonna keep everything except the last part. I'm gonna get rid of everything except the last part. So let's get rid of all of this. But we want to keep that. Come on. That's just how it is. Okay. Delete. So they gave us the initial conditions, right? So when time is 0, right? So if we let t be 0, this guy, so let me see. When t is 0, this guy goes to 0. That's going to be a 1. So this is going to be, so when t is 0, it looks like we have a negative 625 plus c equals 1,500,000. So then is C equal to 1,500,625? Okay. So then it looks like our population based on time looks like it's going to be a negative 25 t e to the negative 0.04 t minus 625 e to the negative 0.04 t plus 1,500,625. Okay, so then what I want to do to check, what I'll do, I'm going to go back to my y equals, and I'm just going to put this in as my second equation. Minus 25x e to the negative 0.04x, close off that power, minus 625 e, what's the time? We got to wrap this up. Negative 0.04x, okay, plus 1,500,625. Now that 625, the units might be different, so that may or may not be correct. Okay, so then what I'd like to do, I want to call on that function. Let me quit. I'm going to just clear this, okay. And I want to call on that function I just inserted, number 2. I want to evaluate it when the time is 24 hours. Okay, so it's been growing. I guess that makes sense. I feel like something is off though. Let's see what happens after 36 hours with this. Okay. So then let me try one other thing. I don't know, I feel like it's off. And I feel like the culprit is this guy here. That's 625. Because like we might need to we might need to adjust it somehow on the right. Let's see, let's take a look at it now. I think I've taken it as far as we can. Okay, I think we did all that. Okay, this looks good. I think we got this. Negative 25. I think we got this exactly. All right. Okay. Oh, 15. See, that's the thing. So we put 1,500,000. I think it was in terms of thousands already. So that's the thing I wasn't sure about. Okay. So let's just make that adjustment. All right. So instead of doing 1,500,000, which this is in terms of thousands, so we're just going to lose those trailing zeros. All right. So if we lose those guys, and then let's just make those adjustments. It's not too hard from there, or too bad from there. Let's quit. Let's clear. 1,500. I guess plus 625. Okay. 2125 is good. Yeah, because I was like, this is weird. I knew that was kind of behaving weird, but I wasn't sure of the proper adjustment. And it's the units. 2125. I don't know. 2125. So then this guy right here becomes plus 2125. And then if we want to adjust that here, we're going to go to y equals right here, this guy. This should be plus 2125. 2125, okay. So then if we make that adjustment, let's just backtrack. Let's go one more. Okay, I just want to recall this one. Okay. And then let's do the 24 one, not that one, but this one. So is that saying 1,655,956? And then this one. Okay, let's see. Because we got to get going. I think we got that. That's fine. Okay, I think we got that. After 24 hours, 16. So the 0 to 24 didn't work. But then when we plugged in the 24, I think we got that one correct. 956, yep. And then after 36, so we would have to subtract those results. Yeah. So we can do like y2. We want to evaluate that at 36 minus y2 at 24. Okay. And 107,729. Yeah, that's fine. Yeah, so we got it. So the only little hiccup we ran into with this one, we just kind of weren't aware of the units because originally we had 1,500,000, but I think that this is in terms of thousands already, so it throws the numbers off a little bit. Just trying to get back to the original. In thousands, right, of bacteria, right? So that part right there where it says in thousands, that's why we couldn't use the 1,500,000. We had to like truncate the last three zeros, the trailing three zeros. Once we did that, then everything else worked out okay. We did our integration by parts okay. We do have a solid 15 minutes, but I think that's essentially enough. Let me just do a scan. So with this one, I think you have to do integration by parts twice, right? So it's something like let u be x squared and du is going to be, or dv is going to be e to the negative x dx. You're going to do it once, you get a result, then I think you're going to have to do integration by parts again. All right, so this one, one of the tricks is sometimes you do have to do integration by parts multiple times, right? So that's essentially what's going on here. Okay, you see that u and then the dv, all right? And then they have to do it again, right? So this one is just integration by parts twice. Yeah, okay. I think that might be it, actually. Okay. So this one is essentially integration by parts three times, but I think you can notice a pattern, right? Like when you go to do it, you can do it three times and it should get you there. Let's see, f of x and repeated derivatives. All right. Sign of the product. Tabular integration, we greatly simplify your work. Let me see, tabular integration. G of x and repeated intervals. I mean, that's fine. But how do we use it? 2 or 3. Okay. So add the products along the arrows, making the alternating sign changes to obtain. Okay. So we got x cubed. The derivative of that is 3x squared. The derivative of that is 6x. The derivative of that is 6, and the derivative of that is 0. And then g of x and repeated intervals, right? And then the sign of the products. So it looks like it alternates, plus, minus, plus, minus. So then they said multiply along the diagonal to get the final result. Plus, minus, plus, minus. Okay. That's interesting. All right, so the integral kind of persists, but then the derivative keeps withering away. So instead of doing integration by parts three times, which is essentially what we're doing with this table, it's just that we just did it in tabular form. Our u originally was going to be this guy. This was going to be our dv. And that dv was going to persist all the way through. And then every time we took the derivative of u, it kept going further and further, getting closer and closer to 0, right? So we can do this. And then we just have these alternating sign changes, alternating signs, right? Add the products along the arrows, making the alternating sign changes to get this guy. Okay, that was an interesting one. Okay, so not too bad. Not the best, not the worst, right? Right, but we got through it. So that officially brings us to the end of the new material, right? So, some of the last concepts that we kind of explored, substitution, U substitution. I still kind of want to go back. The reason I left that other one because I know I'm not far off. I had to kind of like play with it a little bit more. For one of them I kind of skipped. We looked at the answer and we confirmed how to do the integration by parts. And again, when I was working through that, I thought about letting the radical be our TV, but I was like, no, I don't feel like integrating it. I should have tried. I should have just like, well, let me see, right? Just try something different and just try. Like, don't be afraid to not try, right? Or don't be afraid to try. All right, so let me go ahead and make a copy of this. Are there any burning questions before we go our separate ways? Let me make a copy available. Let's see. This one, traditional business notes, updated daily. And this is the last. I do intend to so these recordings are on my YouTube channel. I do intend to organize them. I just haven't done it for whatever reason. So maybe I'll take some time over the next couple of days. So next week we have exam 2. More than likely what I'll do is I'll use like class time as office hours, right? I'll just be here, you definitely want to show up and get your attendance credit. Because if we start reviewing for the final next week, we're gonna have like 2 extra days. So we'll take next week to review for exam 2, covering chapters 3 and 4. More than likely, I'll just be here, and you can ask me questions about anything that you're working on. So if you're working on your exam, we can talk about it, right? I may give you the result, I might not. I might give you a hint. I'll divulge whatever I feel like I can. Maybe I might take it all the way, maybe not. It just depends on what you ask. And then after next week, I think we have 4 sessions remaining after that. And so each session from then on, we'll review each chapter. So after next week, we'll review chapter 1 on Monday. Then Wednesday is chapter 2. Monday is chapter 3. And then that Wednesday, the last day of class, which I think is May 1st, we'll review chapter 4. And then the final will become available. So the May 1st is that Wednesday is our last day of class. And then we have that Thursday and Friday is the reading period. Then that Sunday after the last day of class, let me see, 2, 3, 4. I think it's the 5th, May 5th, something like that. The final exam should become available. You should be able to have access to it for at least like 5 full days, right? So I think I made it become available on that Sunday, and then it's due the following Friday, May 10th at 11:59 p.m. Right? That Friday, May 10th at 11:59 p.m. That's the hard deadline for all assignments, right? So as we approach exam 2, this is a good time. Again, my suggestion for the order of priority, try to maximize your exams first, right? If you are going back, prioritize your exams, get those as high as you can, and then prioritize the homework last. Because the homework is going to be a lot of work for minimal points. The homework is just there to get you ready for the exams. The exams are there to get you ready for the final. Okay. If there aren't any burning questions, we're going to go ahead and end the session here. And from one beautiful mind to another, have a great weekend, guys. You guys are awesome. Again, congratulations to our 2 award recipients. I think it was Martin Edwards and I think it was like a Mr. Tatum, I think. Congratulations, gentlemen. And again, just stop by the math office. You can pick up your awards. And from one beautiful mind to another, have a great weekend, gentlemen. I'll see you next week. Same time, same place. Take care. Peace.